Hello everyone, today I am back with another question of GATE 2026. This question is based on BJT amplifier. I took this question because this question is going to take around 10 to 15 minutes if you solve by the normal approach. But if we go by option elimination, we can solve this question in 4 to 5 minutes. So if out of 4 options, if you are able to eliminate 3 options, then definitely the remaining one is going to be the correct one. So let's see how can we do it. In this question, the input is given as A cos plus B sine, and we are supposed to find the output voltage. So this is an amplifier, and we know that whether it's a BJT amplifier or a MOSFET amplifier, the output is given by some gain K multiplied by input. That means this gain K is a constant value and it is multiplying to our input. So if you look at the options B and D, the input is A cos minus B sine. In D option also, it is A cos minus B sine. But our input is A cos plus B sine. That means in B and D, the input itself is getting changed, which is not possible. So B and D are wrong. So they will get eliminated. So we are left with only 2 options, A and C. So now we have to figure it out of A and C which one is correct. So it is given that the base emitter voltage is 0.7 volts, beta is given as 99, early voltage VA is given as 100 volts. This early voltage is the reason why our question is going to take so much time to solve if we go by the normal approach, because this early voltage is going to introduce a resistance R0 between the collector and the emitter terminal. This is the collector terminal and this is the emitter terminal. Between these two terminals, an extra resistance R0 is going to get introduced because of this early voltage, and this is going to create a problem. This will introduce multiple branches which will make our calculations complex. So first we'll do the DC analysis. DC analysis is very simple, so I'm not going to take much time in this. In DC analysis, what we do is we open circuit this cap gets open circuited and this cap also gets open circuited. So we are left with the equivalent DC model of the given circuit. So first we have to apply the Thevenin's equivalent, which is nothing but we have to find the Thevenin's voltage VTH and resistance RTH at this node, at this particular node. So at this node, the Thevenin's voltage will be the voltage division of this resistance and this resistance. So it is given by VTH equals to 25 by 25 plus 100 into 12. So this comes out to be 2.4 volts. So we got VTH, let's move to RTH. For Thevenin's resistance, we have to ground this node. And when we ground this node, these resistance 100K and 25K comes in parallel. So RTH comes out to be 100 parallel to 25. So this is 20K. So we got VTH, we got RTH. Now we have to apply KVL in this base emitter loop, in this loop. So when we apply KVL, we get 2.4 minus 20 IB. Why IB? Because IB is the current flowing in this base branch, minus VBE, this voltage, minus 1.5 IE. Why IE? Because IE is the emitter current flowing through this branch. We know that IE is given by beta plus 1 IB. Beta is given as 99, so IE comes out to be 100 IB. We got IE. VB is given as 0.7 volts. So let's substitute these values. So we will get 2.4 minus 20 IB minus 0.7 minus 150 IB. On solving this equation, we will get IB as 0.01 milliamperes. We got IB. Now we have to find IC. And the relation between IB and IC is given by IC equals to beta times IB. Beta is 99, so IC comes out to be 0.99 milliamperes. So we got IC. Now we have to find the AC parameters. The first one is the transconductance GM. It is given by IC by VT. VT is the thermal voltage. Thermal voltage is given as 25 millivolts. So GM comes out to be 0.99 divided by 0.2 by 25 milliamperes. So this comes out to be 39.6 milliamperes per volt. R pi is given by beta by GM. So beta is 99, GM is 39.6. So R pi comes out to be 2.5 kilo ohms. Coming to R0, this is the resistance due to the early voltage, as I told earlier. This is given by early voltage VA divided by IC. early voltage given is 100 volts, so it will be 100 by 0.99, so this comes out to be 101.01 kilo ohms. So we got GM, we got R pi, we got R naught. Now we have to go for the AC analysis. In AC analysis, we know that this cap will get short circuited, this cap will get short circuited, this cap will get short circuited, and because of this short circuit, this resistance will get bypassed. So we will ignore this resistance. Also, this 12 volt DC supply will get grounded. So because of this, the exact model which comes out to be will be this. As I told, because of the early effect, an extra resistance R0 is getting introduced. And because of this R0, the total branches which are coming into picture is total 5 branches are coming. So this is the first branch, this is the second branch, this is the third branch, this is the fourth branch, and this one is the fifth branch. So total 5 branches are coming, which are creating complex, we are creating our calculations complex. So my logic is, if we go by the approximate model or considering the circuit without early effect or ignoring the R0, we can easily find the answer, and we just have to compare it with the exact value. Because the options are given, so we can compare with these two values, option A and option C, to get the correct answer using the approximate analysis. I'll tell how we will do. But first, you can see that in this circuit, if I ignore the early effect, then this R0 resistance gets eliminated. So this R0 I have removed. So you can clearly see that there are only 3 branches now. This is the first branch, this is the second branch, and this is the combined third branch. So only 3 branches, 3 equations we can solve and find the answer. So first I will apply KVL in this branch, first branch. So this comes out to be V0 is negative GM V pi multiplied by 5. This is the first equation. Second equation I'll get from this node V. So this will be V by 0.5. I will apply KCL at this node. So it will be V by 0.5 equals to 2 currents are entering. First one is V pi by R pi plus GM V pi. In this branch, 2 currents are coming. One is this and one is this. So I have written that only. So this is the second equation. And the third equation I'll get from this branch. So this node is Vi, this node is V, this node is V, this node is Vi, and V pi is the voltage difference between these two nodes. So V pi comes out to be Vi minus VE. So this is the third equation. So what I'll do is, from this third equation, I'll find the value of VE, which comes out to be Vi minus V pi, and I'll substitute in the second equation. So I'll substitute the value from fourth equation to the second equation. So I'll get Vi minus V pi by 0.5 equals to V pi by R pi plus GM V pi. So let's make the similar terms together. So this will be 2 Vi equals to V pi 1 by R pi plus GM plus 2. So I got Vi as V pi by 2. I have to find V pi. So V pi will be 2 Vi times 1 by R pi plus GM plus 2. So I got the value of V pi. This will be my fifth equation. So I substitute this value of V pi in the first equation. From fifth I will substitute in first. So I'll get V naught, first equation is V naught equals to negative Gm V pi 5. So V naught equals to negative Gm V pi. V pi is 2Vi by 1 by R pi plus Gm plus 2 multiplied by 5. Now I just have to substitute the values. So it will be V naught by Vi equals to minus Gm by 1 by R pi plus Gm plus 2 into 5. Gm is 39.6, R pi is 2.5 kilo ohms. So I'll substitute it. I'll get minus 39.6 divided by 1 by 1.25 plus 39.6 plus 2 multiplied by 5. So V0 by Vi comes out to be negative 9.4. So this is the gain when we don't consider the early effect. Without early effect. And now comes the trick. The trick is when we introduce the early effect, because of the early effect, makes our gain fall. So whatever gain will come, that gain will be always less than 9.4. This is what we were expecting. Like this is the gain this was the exact gain that we wanted to find, and that gain will be less than 9.4. So let's move to the options. So out of A and option A and option C, you can see that option A has a gain of 9.1 and C has a gain of 190.4. And because of early effect, the gain has to be less than 9.4. So you can clearly see the option A is correct one. In option C, the gain is increasing, which is not possible.